this part of the presentation. It's hosted by the Untitled Technology Council. Jay Larson's here, the director. Sam was in the back running audiovisual. Lunch is over there. You guys can grab that lunch anytime. And I'll go ahead and get started with the introduction of Steve. So, Steve, thank you so much for being here. This is Steve Bloomfield. He's director of cloud at Micron Technology. For 35 years, serving the semiconductor manufacturing and various manufacturing and corporate IT roles at Rockwell International, Motorola, Freescale, Maxim Integrated, and now Micron. Steve's passionate about transforming businesses to higher levels of automation, productivity, and quality, and matching technology solutions to facilitate business processes without losing sight of security, talent, and cost. So, thanks, Steve, for coming. Turn it over to you.
You bet. Thank you. Appreciate the opportunity. Just out of curiosity, who in the room uses cloud? Okay, good. Excellent. So as I was going through and preparing for this, I kind of went down memory lane a little bit, and Micron started our cloud journey around 2018, and then kind of had a formal strategy by 2019, kind of the mid of 2019. We partnered with Gartner to kind of help us understand the various aspects that cloud may cause change to in our business. Quite a lot of transformation, especially for IT departments. I remember one of the predictions that they made at that time was that by 2022, so this year, 50% of the workload in cloud would be mission critical. And I remember at that time we were pretty skeptical that that would really happen, because I know where we were at, our minds were at, there was no way we were going to put like SAP production up in the cloud. Well, as it turns out, we have some SAP production up in the cloud already. Our BW is on GCP, on Google. And we have a plan that we're working on right now for an SAP migration for our SAP production environment. So I don't know if 50% is really accurate, but definitely our hearts and minds have changed with regard to cloud, and we do have mission critical stuff up there. So with that, if you would go ahead and let's go to the first slide. There's some terminology that I want to make sure that you guys are able to follow. I think my definitions are the same as the industry, but want to make sure. So next slide, we'll just talk about a few terms. Public cloud, when I say public cloud, I'm talking about mainly the big three cloud service providers. So Amazon's cloud, Microsoft's cloud, and Google's cloud. And by the way, Micron uses all three of them. And if you think about Micron and their situation, you'll understand why. Because the cloud market is a huge market, and Micron sells product to that market. Private cloud, when I say private cloud, I'm talking about an on-prem build, not just of bare metal servers and all that goes with that, but really a hyper-converged infrastructure. So software-defined. It has all of the elements of conventional, hardware-based systems. And what we have in place today primarily caters to Linux containers. We'll be eventually going to Windows containers. We've just finished a POC, and that's looking promising. We have a strategy for that. And then, obviously, virtual. So IaaS will be virtual. Hybrid enterprise, obviously, a mix of all of this, private and public clouds. And, we use all of those platforms, including on-prem. So that's what we actually call our strategy, our cloud strategy, hybrid enterprise strategy. A hyperscaler basically refers to, a cloud service provider. What they have in place in their data centers is a hyper-converged infrastructure. It's software-defined, and it's able to scale in all the various dimensions. Cloud native, this is really where the excitement comes in, the attraction of cloud comes into the picture. It really refers to an architecture, more of the modular, API-based microservices, that kind of an architecture that is able to scale dynamically. And so it's a hardware architecture as well as a software architecture. And then the approach by which you go after the applications, the workloads that you put out in the cloud is also part of that definition. So to go to the next slide, just dive a little bit deeper. you'll hear me talk about IaaS, PaaS, and SaaS. And what I thought I'd do is just over onto your right-hand side of that slide, talk about the technology stack that is associated with each of these and who is responsible for what. So in SaaS, primarily the provider is responsible for most, and then you as an organization would have responsibility for your data. PaaS, you have more responsibility for the application and your data. IaaS, it's kind of a shared model of that virtualized compute and storage and networking gear, and then you have obviously data and application in that model. So private cloud looks very much like a traditional model. You'll see that dedicated IT, that vertical stack is really what a private cloud stack looks like. So I wanted to dive into, one of the big changes in terms of what cloud brings to the table is with regards to the operating model and this responsibility of who owns what in that technology stack. So if you go to the next slide, I'm just going to give an example of what an operating model looks like for public cloud. So SaaS would look different than this. You'd have procurement, you'd have legal, you'd have risk that would also share responsibility in that model. Private cloud looks very, very similar to traditional. So in a public cloud model, where the service provider ends off, then our cloud engineering and operations team takes it, and then with cloud security, and then depending on what service it is, your compute team, your storage team, your network team, your database team, and then if it's PaaS, your cloud engineering operations team will come into the picture. And then from there, cloud uses a ton of automation. You don't really want people going through the portal to provision services. You don't want to give them access to the portal and to be able to do that. You want to do it in a much more automated, in a way that you can kind of control that state, control that configuration. That also lends itself to rapid change, which is a beauty of the cloud and the agile DevOps model. So here's an example of what an operating model looks like and the changes associated with that. I want to dive into infrastructure services provisioning a little bit. So if you go to the next slide, this is one of the other areas that changes quite a bit with regards to the way that an IT department will handle providing services to their clientele. There's typically two use cases that will come into the picture. The top one, we call it a citizen developer use case. They may not really be a developer at all, but somebody in the business who has been authorized to provision certain kinds of services for their organization. We use a cloud management platform for that. So that's what CMP stands for, Cloud Management Platform. It's basically an online service catalog that they can go to and they say, I want one of those, and I want it in this platform, and it goes and it provisions it, basically gives them the key to the service, and off they go. They're very happy. IT's out of it, right? It's like no IT bottleneck there at all. There's the beauty. There's also some caution, because they can go provision to their heart's delight unless you put some governance and controls around it. And then for your application development teams, some cases they may not have a CI/CD pipeline today. They may not be using Agile or DevOps, or they're doing automated testing and releasing. That's okay when it comes to provisioning to the cloud, though. They'll be using our policy. Our standard is you'll be using an infra CI/CD pipeline. And in order to do that, the way that we have set up our shop, our governance around this, is requests come in, I want to use this service, that service, whatever, both for SaaS as well as for IaaS and PaaS. And it goes through an architectural review, and then we'll go through a cloud security review. And then if it's fit for purpose and we can figure out how to put the security guardrails around it, then a base Terraform module will get created for it and added to the repo where the development teams can go and grab it and use it, put it into their development or deployment templates. So going back to that slide that showed the technology stack and the various pieces and who has responsibility, this is the way an operating model is wrapped around that, sharing that responsibility for really readily making services available to the organization so they can use it in a safe and secure manner. So I'm going to pause right there because I've gone through quite a bit. Any questions?
Will this be available later on afterwards, like recorded?
It's recorded, yeah, so you'll get it that way. Unfortunately, I can't get my slides out of Micron. So our security blocks anything coming out. But it is recorded, so.
Where do you think cloud utilization is at today? Is it close to that 50%?
That's a great comment and a segue into my next slide. So I want to kind of talk about the evolution of how the infrastructure architecture has changed and how software architecture has changed. So as you can see at the top, to your question, you look at kind of the average utilization that happens if it's bare server, and then you go into the virtualization world. You obviously get better utilization of what you've installed. And then when you get into that PaaS later, and you're talking about containers and whatnot, the utilization is so much better. And from a cost perspective, it is obvious. When you're using PaaS services, you have a team using PaaS services, they basically pay for what they use. It's obvious compared to an IaaS model. For the IaaS, you still provisioned, some compute and storage. It's sitting there whether you use it or not. PaaS, you only get charged if you use it. So it's quite, I guess it's one of those beyond my expectations, beyond my dreams. I couldn't believe just the difference between an IaaS cost model and a PaaS cost model. So
As a user, you don't have to buy it or maintain it.
you just use it, yeah. Yeah, it's a totally managed service. So on the software side, the way that application architectures are evolving, obviously going away from the monolithic, everything is integrated and coupled together. It's very tight coupling. You want to make a change, sometimes the change is pretty simple, but in order for that change to work, you got to go touch all these other integration points, and thus sometimes the change takes longer, just to get that done. And scaling it too, everything, right? If you just have one function of your application that is getting all the demand, and you need to scale, if it's a monolithic architecture, basically you have to modify your infrastructure architecture to cater to the whole thing scaling. So whereas on the cloud native side, which is really where the beauty and the excitement is, it's more modular based, more microservices, you can scale just that piece. So it's more of a surgical customization that is possible as opposed to having to deal with this bigger entity. So a little bit of evolution on kind of where things were and where things are now, and the beauty of IT. It's great being an IT practitioner because you can definitely focus more on what the business needs than on all this other enabling stuff to get in there. All right, let's go to the next slide. Talk about this just a little bit more, comparing traditional IT to cloud native from these particular dimensions. Architecture, we've already talked about. One of the aspects, though, that I do want to dwell on a little bit is this concept of scale up versus scale out. So scale up means that I have an application architecture, and in order for me to go to something bigger, because I've got more demand that I need to deal with, I have to bring in bigger boxes. And then a lot of times, in order to do that, I may have to turn that thing off, have a down window in order to go do that change. So scale out means, and today, if it's virtualized, you can actually just automatically, in a lot of cases, you can automatically move to a bigger VM, right? You just reconfigure your image and your VM to be bigger, and you can change. A lot of times you don't need downtime to do that. On the scale out side of things, all you're doing is bringing in another worker node into your pool. So it will scale out and in dynamically. You don't have to manually say, hey, I need another one. You can set thresholds and say, hey, if I get to like 75% utilization of say CPU or memory, whatever it is that really kind of drives your application, then it will automatically just add another node for you. Or if it goes past a certain threshold, then it will take a node out, right? So you're getting closer to really paying for what you utilize in these cases. Cost, I already talked about that. It's amazing what PaaS looks like versus IaaS. Delivery as well, when you have more of that modular case, you can just go surgically right to that particular thing and make those customizations and roll out that change, as opposed to there might be a lot of baggage that you're carrying around when you need to make a change on the monolithic architecture side. Teams can use that agile approach in cloud native. Infrastructure side, we talked about that. The infrastructure hyper-converged infrastructure versus more of the bare metal virtualization. So in a nutshell, there's the beauty of cloud right there. That's why it's so attractive. So you imagine your development teams, what their life would be like on that side, right? They're so much happier. They're fun people to be with. They don't have to wait for that infrastructure team to go, put in place some additional compute and storage. So, all right, I'm going to try and summarize now benefits. We've talked about quite a few benefits, but I want to, make it clear. These are kind of the main areas that you're going to see benefits in. We've talked about agility and speed, scalability and cost. On the security side, this might not be real obvious, but I've kind of alluded to it with our operating model and our governance and how we make services available for use. It goes through, a security review. We identify our guardrails, and to provision, right? We make sure that they provision with our base Terraform modules, which has the security guardrails in it. So when it's provisioned, it's secure. But then it could drift, right? And the beauty of the cloud is you can write policies, such as configuration, that can constantly be looking at whatever time threshold that you want at the entire footprint that you have out there. And if something has drifted, it can flag it, but it can also self-heal. It can remediate right then and there. Oh, you've opened up an IP to the internet? No, sorry, boom, gone. It's closed. So that's the beauty of security in the cloud, is it brings that automation, brings that ability to apply policies really easily. On the on-prem side, you got to build that yourself. So it's possible, but you got to build it yourself. Talked about optimization, reliability, and resiliency. Yeah, any architecture is possible. You need high availability, you can achieve it. You need geo-redundancy, you can make that happen. You need DR in the cloud, actually more cost-effective than trying to do it yourself. So, somewhere else. All right, next slide. I also want to summarize some of the main changes that hit the scene in the cloud world. And some of these we've already talked about. On the demand management side of things, one of the big eye-openers that we ran into is, hey, we're building a cloud team. OMG, so is everybody else. And we're competing against the Googles and the Amazons and the Microsofts and the Accentures and the Deloittes, and going after cloud skill. And we do quite a bit of partnering, certain kinds of projects that we do. I've seen like Accenture bring cloud skill to the table and then lose them. So it's very volatile. When we started to build out our team, we did a look-see at the market. There was 3 times the demand than the supply for cloud skill. So demand is, it's a challenge. Demand within the organization eventually will become insatiable as well. And that is if you have a cloud-first policy that's truly in place, and you have teams that are say, oh, hey, CIO, hey, guess what? I need to scale up. I need a bigger box. Yeah, I know I'm not quite, at the end of my life cycle of what I've currently got, but we can't upgrade because, I need more hardware, I need more compute. And it's like, well, have you looked at cloud? Right? And so if you have your executive leadership making sure cloud first is first, and you have some, readily available some TCOs, some total cost of ownerships that you can show, then it will go cloud. I've never done a TCO yet where cloud doesn't win. Even if it's on equal footing, it's going to be the same. But most of the time, you're going to have incentives, you're going to have discounts because those guys are hungry for your business. And so at least out of the chute, it's going to be better in the cloud from cost perspective. So we talked about enterprise architecture and those changes that are possible. On the data side of things, you guys are probably aware of how data just copies of data, right? Gets slung all over the place. Redundancy, tens of thousands of data pipelines. Well, that will become even more, exacerbated or worse in the cloud if you don't have a good cloud strategy. So we don't quite have ours in place yet, but the direction that we're going is more of a data virtualization. So we have sources that are going to provide information to a data virtualization layer, then from there to the applications that need it. So API-based. Finance and budgeting, what comes into the picture here is this new entity called FinOps. finance operations. And the reason why is because what you're doing in the cloud is observable. It's got tags in your billing. They have various meters. You can see it really easily. You know exactly what you're being charged for, what services, how much of that service. And if you've tagged it correctly, you know whose application, who owns it, what support team, what environment. And so with that information, you can really scrutinize your cost. And even the platforms have recommendation engines. They'll say, hey, did you know that this thing that you have over here hasn't been used for 30 days? Or the amount of usage is really low. Maybe you should look at this other machine type, a little smaller machine type than what you're using. So a lot of signatures are already being applied to your cost, your consumption, your usage. And so there's this entity called Finance Ops or FinOps that will come into the picture and specifically start looking at how they can optimize that cost. And a part of that is because of the CapEx versus OpEx. It used to be that capital was really hard to go after. That was one of our constraints. Should we look at our portfolio, what that portfolio would be constrained because of capital. Capital and consulting were the two main constraints. Guess what it is today? I can get capital. Holy crap. I can spend all the capital I want, but I don't have the OpEx for it. So it's a limiting factor anyways. But so that's the problem that's happened is now OpEx. I was able to go, I basically had a blank check. I could grow the cloud as much as I want, to my heart's delight. Go adopt cloud, right? But now we're, tens of millions of dollars a year on cloud. It's caught up with us. Now we have to be really careful, right, from a budget perspective. Let's see, governance we've talked about. I highlighted security and service management. All of that, kind of changes your game quite a bit. Sourcing and procurement, I probably on a daily basis have 2 or 3 conversations with my procurement partner. There's so much dealing and willing that goes on with the cloud providers, and it seems like it's constant. They see where you're at. They see, what you're using and what you're spending is maybe over what your, if you have a spend commitment, what your spend commitment is, and they're hungry for trying to give you more incentives in order to increase that spend commitment. Because that spend commitment for them is, it's revenue, right? It's committed revenue. So, let's see. Oh yeah, on the strategy side, I kind of alluded to this in one of the examples, but yeah, there's freedom in not having, I guess, 100% ownership of an IT asset. So if it's the cloud's asset and what I'm currently using doesn't work anymore, I can change it. I can pivot like that. But if it's mine and it's sitting in my data center and it's something that's no longer viable for what I'm using, all of a sudden I have a problem. Well, who's going to use this now? How can I repurpose it? Do I have to write the whole thing off because nobody can use this now? So there is some freedom that comes with that, and your executive leadership will eventually latch onto it pretty quickly. All right, so those are kind of from a benefit summary and from a paradigm shift summary, those are the main things, trying to paint kind of the big cloud picture. So I'm gonna try and bring it all together by sharing an actual example. Hopefully you guys will see the beauty in this. So on the left-hand side would be a traditional approach for this particular application. It needed to be global across 7 sites. In order to do that, we would have been using multiple load balancers, VMs. It had to be a globally distributed and kept in sync database. It would have taken us, to go procure that, install it, get it all set up and ready to go and deployed, probably at least 4 months, right, to make that happen. So this slide almost makes me want to cry because it took less than a week to go put this in place. Less than a week, and you look, okay, I'm using containers on private cloud. I'm using a Cosmos DB, which is a PaaS, globally distributed database on Azure. So I'm using public cloud. I have an application architecture that's hybrid. And then you look at the benefits, obviously speed, the ability to scale dynamically. I don't have anybody there that has to watch this thing on the private cloud side or on the public cloud side. It will scale on its own based on demand. And the cost is just incredibly so nice and juicy. So, all right. right, let's do one more example. This one I just had to throw in because I wanted the opportunity to kind of toot the horn about semiconductor manufacturing. Micron's a semiconductor manufacturer, by the way. They make memory, they make storage. And one of the examples that we had recently had to do with what we call a reticle or a mask. And if you think about painting, you know, where the places where you don't want the paint to get, you'll mask it off, right? This is basically the same thing that happens here with creating a memory product. So this thing right here is called a wafer. You grow this big long cylinder of silicon. Silicon is a semiconductor, meaning that it doesn't conduct one way or the other. You have to do something physically to it for it to conduct. And you cut off, you know, these pancakes out of that cylinder. That becomes a wafer. And then each one of these squares is basically a memory product. And this reticle is the thing, so you can see this right here. The light comes through that reticle, which masks off part of that chip on the wafer. And literally what is happening is the light is the pen or the pencil that is writing or creating the circuitry. And the reason for light, this is the thing that is so cool. I'm an engineer, okay, so sorry. I get really geeky about this, but the thing that's cool about light is it does have physical dimensions to the spectrum of light. On the light side of light, the wavelength is larger. And on the dark side of light, it's smaller. And so in order to get the smaller dimensions, you use the darker side of that light spectrum. So this particular problem, they call it EUV, extreme ultraviolet. So it's on like that very last edge of the light spectrum. It's using that wavelength to create the small geometries that we're able to achieve in our memory products. But the problem is that it requires so much more data to get processed. And this data has to be processed within 3 days. In order for this step in the product introduction lifecycle to take place properly, it has to be done in 3 days. Well, with EUV products, because of the amount of data, additional data that is required, it's going to take 50 days to do that, as opposed to 3. So it's like, oh my gosh, what are we going to do? We don't have enough capacity on-prem in order to provide the compute power to process all this data. So we said, well, what about the cloud? Cloud first, right? So we go to the cloud, and in 3 weeks, we have a parallel cluster up that is able to scale, 80,000, 120,000 cores, whatever is needed, and get this done in 3 days. So pretty impressive. It costs a lot, but it's pretty impressive. All right, next slide. Let's see. Yeah, I'm doing okay on time. I also wanted to talk a little bit about an aspect of cloud that will eventually come into the picture, which is more around, we call it brownfield. It's more about your legacy applications. A lot of what I've been talking about is more on the greenfield side. All these new features and capabilities, and they're always emerging from the cloud environments, cloud platforms. And that's the fun stuff, right? That's where cloud native is. You go and grab those services and use them in your architectures. But you still have a lot of stuff still at home, right? So what do you do about those? And we still call that modernization. And our objective is to eventually be 90% cloud, which means that it's not just the greenfield side of the house, it's also our legacy app side as well that needs to be figured out and migrated to the cloud. So how do we do that? So one of the things that we talk about is modernization, and behind modernization, there's a couple of motivating factors. There's the supply side, which really comes from the business. I want this new thing, right? I need this functionality to stay competitive. I need these new capabilities. And that's typically where most IT departments focus is on satisfying, that new portfolio of all these projects that the business needs, right? But what about what is existing, all the tech debt, and you have stuff that no longer even has a roadmap for it and that you're using in your application architectures. So there's the IT side of it as well in managing that side of the house and making it less of a sustaining burden, right? So there's those two drivers, and then on the next slide, we talk about these two drivers will bring in new functionality and new architecture, or it may be new architecture because you need to change out the technology. And if you go to the next slide, then it introduces all these R words. And this is kind of what you'll see in the industry, especially when it comes to cloud, and you get the Accentures and the Deloittes and the others that are coming knocking on your door and saying, hey, I want to help you migrate to the cloud. What they're talking about doing is these R's. because that's where kind of the low-hanging fruit is. And what rehosting means is that what I have on-prem, I can achieve in the cloud. I don't need to make any change. I can just move it. But a lot of times, what you have on-prem comes with a lot of dependencies. I may have an authentication technology that I don't want to use anymore. I don't want to deploy it in the cloud. And a lot of times, it becomes a kind of debate or a fight between executive leadership wanting to accelerate and your architecture team saying, I want to adhere to some standards. Gosh darn it. You know, we're not taking that crap to the cloud. Well, when they want to accelerate, usually there's compromises that happen and some of those dependencies end up coming into the cloud. And that's so that you can do more rehosting. So now if you can get away with some of those changes, then maybe replatforming is where you're changing out the OS. Refactoring is, okay, I'm using Oracle on-prem, and Oracle supports Oracle on-prem. It's great. But if I have Oracle in the cloud, guess what? Oracle only supports Oracle in their cloud. So what am I going to do? So I might need to do a database technology switcheroo. So as you go up the scale, there are obviously more effort, more impact, and it will take longer to ready that architecture for deployment into the cloud. So if you go to the next slide, this is just a quick example of what a migration journey would look like. You'll take your applications, all of them, take a look at them, assess them. There's a number of tools that are out there to help you identify what's good for public cloud versus what should stay on-prem, maybe in a private cloud setting. Once you've gone through that, you've figured out your candidates, where they're going to go, then it's where the R's come in. What am I going to do with each one of these? This one I can rehost, I can move it as is, I got everything in the cloud that I need. I don't need to change it, I don't need to touch it. This one is using RHEL 6, and I'm not putting RHEL 6 in the cloud. So it's got to be 7, 8, or better. So it might be a replatform. Or I've got some re-architecting to do because there's some things in this application architecture. It doesn't even have a roadmap, not even supported. I'm going to change it out before I take it over. A lot of times what you try and do is bring over as much of the dependencies as possible, get that rehosting or replatforming done, and then modernize from there. So, and a lot of times the modernization or the migrations are done in what they call waves. And you'll do your easy stuff first, and then stuff that will take more time, be in later waves. So that is the spill on cloud for today. If you hit the next slide, then I'm more than happy to answer any questions.
So obviously security is a big deal. You hear about hacking all the time. So is it better to have your in-house security, or is the real expertise in the cloud?
No, we actually have a cloud security team. So we ended up, I would say, even before we fully staffed up a cloud engineering operations team, we had a fully staffed cloud security team. And it is in-house. So we're not going to be dependent on any external entity, in advising us or telling us that we're secure. So yeah, we had to grow them. We had to buy whatever skill set that we could and track them in, and we have our own cloud security team. And by the way, they're the ones that develop the base Terraform modules. So
is that a local team, or did you have to go elsewhere?
It's global. So we're split mostly here in Boise, and we have a global development center that's in India, in Hyderabad. So
how's the labor market side of that here in Boise, as far as finding talent?
Oh my gosh, it's like impossible. Now, luckily, most companies are kind of like Micron when it comes to cloud positions. They're okay with remote. So some of that is starting to emerge. And sometimes you can't even attract talent unless it is a remote position. The other thing that we face from the talent side is, I don't know if I should say this on tape, but I feel like we're using antiquated job families, right? They're using Radford, our HR compensation teams are using some of those traditional benchmark studies, right? And it doesn't necessarily include cloud families. And so we end up having to jack up, usually when you bring somebody in new, you try and get them, somewhere below mid of that salary range, but we end up jacking up that that to go over it. So
you mentioned you guys are multi-cloud. How do you manage this multi-cloud approach you guys have? Being in Azure, Amazon, Google,
yeah,
having in GCP, whatever. What's the
very, very carefully, and the reason why is because this is actually a very sensitive political thing for Micron, because they are also our customer, big customers. And so we're trying to be as equal and fair as possible with what we use each of the platforms for. And so we went through a very long, and I want to say exhaustive, set of POCs in trying to, from a technical capability standpoint, understand what each of those platforms really is good at. And we know that they're going to close the gap on technical capability over time anyways. So like when it comes to Google and data analytics, machine learning, artificial intelligence, data lake, that kind of stuff. I mean, if you look at the three biggies, they grew up in the cloud from the get-go. They get it. And their ability to manage data is just impressive. So that was a pretty easy decision. And we use that platform pervasively. It's one of the bread and butter of semiconductor. You look at that wafer, right, and you have all those chips on there. You want that wafer to yield as much as possible, 100% of those as good chips that you can sell, right? Because that's a lot of material. To build one of those is 2-3 months cycle time, right? And so any scrap is just it's very costly. And we use machine learning, artificial intelligence, all these data analytics to apply to the designs into the manufacturing process to eliminate or enhance yield as much as possible. So that platform has grown just gangbusters, and they're moving. They'll have their Hadoop and other analytics basically off and out of our on-prem by the end of this calendar year, and everything will be in GCP. So, and then for our manufacturing uses Microsoft technology. So it was pretty much a no-brainer to stick with Microsoft Azure for them because of all the integrations that they already have. It works really, really well. And then a lot of our engineering is engineering and our legacy applications will be primarily on AWS. So AWS is the one that when I talked about the mask problem that we had where it was going to take us 50 days to do that process versus the required 3, that's where we went, was to AWS. They have, from an availability, they're more mature. They have more out there, more regions. And from an availability of what you need, you can find it there easier than the other two.
So I guess to follow up on that, what prevents your team from being siloed, where you've got Azure connects, AWS connects, Google connects? From a security perspective, just curious at your guys' size, how do you kind of keep the governance model with all those kind of interconnects across the different? You see what I'm saying?
Yeah, from a team.
Kind of where do you guys meet in the middle, I guess?
Yeah, from a team perspective, we've tried not to silo anybody in any particular platform, but we know when we hire them, they're going to be strong, in they're going to have an experience, right, in one or two. Private cloud is probably even harder than the public cloud side. We're using OpenShift, Red Hat OpenShift for that. From a governance perspective, right up front, we have, in order to be able to use cloud services, they have to go through a governance process that does an architectural review. So fit for purpose, first of all. Is this something that we would say we would adopt as now part of our architectural standards? It will go through a risk review. If it's SaaS, so we've already done risk review for the three cloud service providers, right, that we use. And that will be an ongoing basis where we look at risk. If it's SaaS, it will also include legal and procurement. Cloud security will come in. And then from there, it will go to implementation. Or if it's SaaS, it will go back to procurement for a contract negotiation. So we have this control up front in terms of what we make available. And each platform probably has, I want to say, about 50 services. We call it whitelisting. Everything is basically blacklisted, right? Can't use it unless it's gone through this process, and then we've whitelisted it and made it available. And then even from there, being able to provision those services requires obviously some budget control. So there's a budget manager that gets involved as well. So, but right now what we're trying to do is grow our FinOps side, because from a cost perspective, OpEx has now become a constraint, right? And so with the way things have gone, recession-wise and whatnot, we're trying to, I want to say scale back or optimize the cost, but still be able to free up room to bring in workloads that are a priority and continue to still grow. So,
With innovation that happens in your company, is it usually top down or bottom up? Meaning like from an engineer standpoint, pushing it up to the C-suite and saying, okay, C-suite, this is cool, we found this innovation, it's going to make our lives easier. Or is it C-suite going, okay, dev team, implement this because we're sold on it, and it's going to make your life better?
yeah, I think it's a combination of both, but there's definitely certain visions that come from the top. Like the cloud thing really started at the top more than it did from the bottom. And the reason for that is because our CEO is constantly asked, why is your team not using Azure or Amazon AWS or GCP? So he was constantly being bombarded, and so it was because of him saying, we got to go use this stuff, guys. Where's our cloud strategy? And that really helped get things going really, really quickly. But I think when it comes to strategic leadership, it's really, in order for it to be effective, the bottom and the top really have to kind of align and gel on something in order for it to really take off. Otherwise, you'll have passive resistance on the bottom, right?
Yeah, you said everything's blackballed until it's whitelisted. So how does innovation happen then if everything...
Innovation happens because each one of these groups have a business partner that wants to go in a certain direction. And so from an architecture perspective, we're looking at how to satisfy those directions, those capabilities. And a cloud ends up being one of the main tools that satisfies what they're looking for. So it's kind of, yeah. And when it comes to data analytics, their vision, I mean, there's a whole organization, they call it, I think it's technology, it's TPG, but it's the group that manages the technology around how we manufacture to satisfy the product designs that are coming out of the chute. And this is a group of thousands of engineers, data scientists. And so they're just pounding on that GCP with all sorts of ways of trying to figure out how, what do we need to go change, say on on that reticle slide that I showed you, the tool that is used to create that is called photolithography tool. That tool, what do we do to the recipe on that tool to tweak a parameter so we can improve the yield, for example? Or even to that mask, right? What additional information needs to come in and be processed as a part of that analytical job so that mask is even more accurate and we have better, tighter geometries on there.
So you're virtualizing the process and they're just trying to find the best way forward. They do that in real time on your cloud?
When you say virtualizing the process,
they're trying different things. They're trying to see.
Yeah, there's a ton of innovation. Yeah, that's the point I was trying to bring up with the data scientists is you have to be careful because when you start something learning, that machine learning requires a model, and when you start that model learning, it can suck up a lot of compute and give you nothing at the end of the day, right? So they have a whole governance model around the different use cases on what people are proposing. Hey, if we go do this, we think we'll get this outcome. So yeah, a ton of innovation comes into that picture very quickly. A lot of ideas. The cool thing is that innovation is so much faster because you don't have to wait for IT to go provision additional stuff to enable that, right? That's the beauty of the cloud. It's right there at the ready. But you got to be careful because they'll go turn it up like crazy. And they have. Can you imagine an extra $1 million just showing up? I'm spending an extra $1 million a month now for this? What happened? You're $1 million over your budget. What are you doing?
Joe had an idea.
Oh, but it's good. Yeah, exactly. Yeah, you take this to the CEO. He'll back this up. Oh, really? You go get that approval for me and let me know that I've just now been authorized to increase my budget by $12 million for the year.
We want the FinOps guy, so we can just get the button.
I need that FinOps guy, yeah. So.
Well, then it's where's the savings? Where are we getting that 12 million back?
The offsets, right? That's where the CIO is constantly asking that question. Where's the offsets? In a lot of cases, like in this mass case that I shared, there's no way we would have gone and got approval for the capital to go put in place 80,000 to 120,000 cores. There's no way, because we're using it 2 or 3 times a month, so the rest of the time it's going to sit there. But in the cloud for a burst case, yeah, makes sense. But that's CapEx avoidance, right? There's no offset there.
Do you have to tell that financial story, or does FinOps do that for you? Like when you wanted to move to the cloud, was that you championing from the money side and having to talk about money?
No, that was the business. Yeah, that's one of the, I guess, downfalls of, I don't want to call it a downfall, but challenges of IT is where you kind of caught in the middle, trying to defend, spend. It's really the business's responsibility to defend, I need that technology, and this is the reason why I need it. That's when it makes sense, right? This is when it becomes business value. And so, in fact, what we have recently done, we had all of the cloud spend tucked away in our infrastructure and operations. So even within IT, right, we have departments that kind of partner with manufacturing, partner with engineering, partner with the back office, right, all of our enterprise apps. All of their cloud spend was tucked away in infrastructure and operations, which enabled these IT organizations to partner with, their business partners. So because with OpEx has become such a scrutinized spend now, we're moving that cloud spend out of I&O into each of those departments, so that it's more closer to where the consumption is, and they with their business partners can go and defend it or add to it or whatever. So
yeah, Steve, this is interesting. So can you talk a little bit about that migration? How long have you been with Micron?
5 years.
5 years. Can you talk about the migration, like from the data center days to where you are today, and also how the team is so important, because like a non-Vol is a fantastic guy, right?
Yeah.
So as CIO, that's visionary of this team. I mean, talk about that if you can.
From an evolution standpoint, we will always have data centers because we have manufacturing. And our standard pattern is 2 data centers per factory. So you have automatically the ability for some high availability as well as DR. So if something happens at this site, but I can still potentially run, but both data centers are down, I can go grab a data center from another site, right? So we'll always have that, and that's why we have a private cloud strategy, is because of the tools that we have on the floor that require that latency availability in order to know what they're supposed to be doing at any second in time. Is going to eventually, it may go to the cloud. Public cloud may eventually get there with the latencies that we need, but today it's not there. So we will always have data centers, but the evolution of what we have in our data centers has definitely drastically changed. So if it's something that definitely can be done, like even SAP production, 4 years ago, we would have flat out said it's not even on the table for discussion. And now we have a migration project that's in the works. So if it's possible to move, it will move. And I think right now we're kind of thinking our split between private cloud and public cloud in terms of what's in our data centers, it'll probably be about a 60-30 split. Yeah, that's where we think we'll land.
I love the business units you were talking about, because how does the leadership play in all this transition and what they've been doing?
They're very supportive. Yeah, they get it. It kind of goes back to that paradigm shift. I talked about strategy, and I talked about the leadership. Yeah, that executive leadership, once they understand the freedoms that they get by going to the cloud, they're all bought in. Yeah, and they want more. Yeah.
What's been the biggest challenge in your public transformation journey?
The biggest challenge is skill set. Is really trying to find and attract and retain the skill. And a lot of times you'll end up having to kind of build it up. So we end up kind of being the gating factor on moving faster, because we don't have the positions filled that we need in order to support it and enable it. So
skills being one of the hardest things that you come across, is it because you guys are having to spool everybody up and then they leave for greener pasture?
Yeah, we get a lot of that.
You do that same cycle over and over again?
Yeah.
So why haven't you guys implemented infrastructure as code?
We do.
Okay.
That's exactly what Terraform is the base Terraform modules is IAC, software defined stuff.
So have you found found that's helpful in terms of?
Definitely, because you're not dependent on a person knowing how to do those kinds of deployments, right? It's all right there. It's all in code. So now you can bring in a new person and they can pick it up. So, but yeah, I mean, it's problematic, especially in India. So,
What do you want to see, maybe experience-wise or qualification-wise, for those people that are coming in? Do they need, how much experience do they need to come into your program?
to be honest, the bar's pretty low. Even if they have a certification but no experience, we'll think about it. So, I mean, there was a point in time probably about 3 months ago where I was down to one person on my cloud engineering operations team. And I'm spending tens of millions of dollars a year on cloud.
Is there a program with the local universities to help with that?
That's a good question. No, I don't know. I'll have to look into that. But yeah, it'd be great to build a pipeline, especially here in Boise. It is hard to find this skill in Boise in particular. And that would be the preference, right, is to have those positions here.
Isn't the expansion going to kind of disaster?
Oh, yeah. Yeah. Expansions. Yeah. Yeah, did you guys hear about the New York announcement as well? Yeah. Mega fab. Up to four 600,000 square foot clean room facilities. 2.4 million. What's that?
Did you break out the sweat?
Not me. I'm not manufacturing IT anymore, so.
But you're going to provide the containers for them, right?
Oh, that's true. I guess I hadn't thought that far yet.
So
Yeah.
I guess I have a question. As like a smaller IT team that's already pretty invested in cloud, like where would you recommend they focus like their manpower or like skill searching to help make sure they're taking advantage of, you know, the cloud that they're already invested in?
Which cloud are you talking about? Is it?
Well, I mean, we're like my organization's pretty heavy in Azure, so I mean we pretty much run everything through Azure. So.
Are you asking like from a development standpoint? And
Well, like I said, just as a small team, like where would you, focus your staff on?
definitely would be on the training that they offer, and the training is free. If you do computer-based training, you have access to it, and they have really good certification paths as well, which we advocate. When we started, we weren't really that high up on certifications, but because you can get people that are certified but no experience, and then we realized that a lot of times we can't even attract people that are experienced, and so if they have a certification, at least we're starting with something, right? So, but that's what I would do, is make sure that on a yearly basis their development planning includes, based on their position, if they're a cloud developer or a network engineer or a platform administrator or data scientist, that they are going back and they're refreshing if they've already gone through certifications, but they're refreshing because it's always changing. I mean, the services that are emerging, they're coming out left and right. There's a large army of people around these platforms that are pumping out stuff. So,
Do you agree that no one cloud fits all? I mean, what's your stance on that?
I would at least have two.
Yeah.
So you have that flexibility to be able, because if they realize that they are it for you, it's harder to negotiate kind of the deals that you will want to achieve. So I think having that flexibility definitely plays in your favor, because then you can basically threaten and say, well, you know what, AWS is giving me this, right? Or so.
That's generally across the board.
Yeah.
Eggs in one basket.
Yeah, don't put all your eggs in one basket.
I'll cover up my shirt, but that's the way you hold us accountable.
Yeah.
Yeah.
So. All right, well, it's been quite enjoyable.
Thank you.
You bet.
Cheers for Steve, right?